Hello everyone, and welcome back to another quiz tutorial. I'm just going to call it quiz. And today, for those of you guys who want some new material, you're in luck. Because in quiz 6 today, we're going to be talking about the change of basis. And this is something that you guys haven't seen before, so you haven't seen in Eng 130, and you haven't seen it in linear algebra, so it should be something new and exciting, and something to scare you moving forward, because this is where students start to go, oh, this is why continuum mechanics is difficult. And it's honestly not that difficult. I think the hardest part students have with this is just figuring out what exactly is going on. What does change of basis exactly mean? So I hope to cover that a little bit in the theory, and then it's nice. The quiz itself is only one question, and it's very, very simple. And then there's a little trick to the question, which will make it even more simple. And that's a trick that I really encourage you guys to use during final exams or midterms. I guess in this case, it'd be on the midterm, not the final. So with that being said, to help you guys understand what change of basis is, let's take a little quick look at the theory. So to help describe what change of basis exactly is, let's just take a very, very simple case. And fortunately for you guys, this is the simple case that's also on the quiz. But let's say that we have a vector in 2 dimensions in R2. The vector's name is u, and we have the current coordinate system. The coordinate system is based on E1 and E2. That's the basis set, E1 and E2. But then we'll go, you know what? This is great, but I prefer this. So basically all we did is we took E1 and E2 and we rotated them by an angle, theta. Now, the vector itself, u, didn't change. But if we change the coordinate system by changing the basis, E1 and E2, now known as E1 prime and E2 prime, the coordinates of u are going to change. And that's why instead of u, in this coordinate system, we have something called u prime. And I think this is where students get confused because they understand the idea of this. Yeah, we rotate the coordinate system basically, so we're going to have different values, but why the hell are we doing this? This just seems like work that we don't really need. We usually stick to our nice Cartesian vectors, stuff like that. But you guys will actually find that later on in the course, and especially in higher level courses, I guess would be the word, it's actually easier to solve equations when you get into the big nasty partial differential equations. It's easier to solve them in a different coordinate system. So let's say that if we were to solve for u in a higher level course, what we could do is we can transform the system into E1 prime, E2 prime, solve for u, and then convert it back. And it sounds like a lot of work in this scenario. Trust me, it is. But when you're dealing with big nasty partial differentials, it actually becomes a lot easier because some of the equations might be coupled, so we can uncouple them, stuff like that. But you guys don't need to know that. All you guys need to know is we're rotating the coordinate system, and since we do that, our u vector will have new coordinate points. So basically, the goal of this is to try and find a matrix. We call them tensors in this course, and there's so many names for them, but basically there's a matrix, or I guess linear map even, but we have this matrix Q that transforms our basis from E1 and E2 to E1 prime and E2 prime. And what that Q does is it allows us to transform our vector U into U prime. So the question becomes, okay, well, how do we find U? Luckily for you guys, there's a nice easy formula, which is Qij is equal to E prime I dot with Ej. And then we can expand that out into matrix form. And I know a lot of you guys will, wait, Clayton, hold on one second. How do you go from one bullet to a second bullet or to a matrix, something like that? Don't worry about it. This is something called Einstein notation. It's covered in kind of higher level up continuum mechanics courses, something you won't need to know. All you guys will need to know is that the formula for Qij is equal to that matrix right there. So we got E1 prime dot with E1 and so on and so on. And it's important to recognize that right there, that's the dot product. So if we take the vectors E1 and E1 prime and dot them together, we're going to get a single scalar value. So in the end, we'll have our matrix Q. Now, here's kind of the hints I'm going to tell you guys. This formula right here can be used to derive basically anything in R2. But very rare does Dr. Adib give you anything crazy. And what usually happens is he just gives you a nice rotation. So in the case above, shown in the top right, our Q for a simple rotation of the basis is going to be cosine theta, sine theta, and then on the bottom, negative sine theta, cosine theta. Now, during the example, I'm going to show you how to solve it nice and quick just using this formula. It's basically just plug and chug. And for the midterm, that's what you're going to want to do. You're going to plug and chug your way to victory because all you guys are interested in the marks. Let's be honest, no one cares about the theory. So when I get to the example, I'm going to just do it nice, quick, and easy to show you guys how to do it on the midterm. But then if you guys want to stick around to the end of the video, I'm going to cover how we go from the E1 prime dot E1 blah, 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 blah to cosine theta. I'm going to kind of show the little bit of proof for that. So it should hopefully make more sense. So let's jump right into the quiz now that you guys know the theory. Like I said, nice easy quiz, one question. Let's do it. All right, so the question says, consider the basis set B prime, which is composed of E1 prime and E2 prime, where the new basis vectors are rotated 60 degrees counterclockwise from the original basis vectors E1 and E2. Let U equal U1 E1 plus U2 E2, which is equal to 2E1 plus 3E2. Determine the components of U prime and the new basis system. So to get a better understanding really quick of what exactly we're doing, let's just draw a little diagram. So originally what we have is something like this. Let's say, oh, I should probably actually draw this right in the center because I will look like an idiot if I don't. So let's just say that these are our original basis vectors, E1 and E2, something like this. So we got E1 and we got E2. And if they're orientated in such a way like this, we know that E2 is going to be 0, 1, and E1 is going to be 1, 0, something like this. And in this current basis system, we have a vector U. And the vector is going to come out, let's say, it's higher than this, so let's say it goes something like this. So this right here is going to be U, not to scale, of course. And if it says that U1 E1 plus U2 E2 is equal to 2E1 plus 3E2, it's very easy to see that U is going to be 2, 3. So this is what we originally have. And then, they say, okay, this is great, but let's change that basis. Keep students on their toes, something like that. So instead of having this system, what it wants us to do is calculate the components of U if we switch the system to this right here. So we have, this is our new E1, and then on the other side, we have E2, something like this. I'm going to try and make it look nice. I'm not an artist. Please be nice to me if you don't like it. So this is E2. And since these are our new coordinate system, what we're going to do is we're going to put prime. So this is our new basis right here, this E1 prime, E2 prime. And the angle between the new basis system and the original one is angle theta, which we're given is 60 degrees. So the whole goal of this question is basically saying, okay, well, we had U in the original basis and it had coordinates 2, 3. Now, when we rotate our basis system, what are the new components of U? So in order to do this, we go to the nice formula that we're given before, where it says the coordinates U prime are going to be equal to a matrix Q times the original components U. And luckily for you guys, I gave you this nice formula. And remember, if it's a midterm, just use the formulas, write it down. It's an open book test. Use those formulas, go really fast, because that's what it's about. We're not testing you on the theory. Unless you go to grad school, then yes, the theory will be very important. But as I remember saying it, for this particular scenario where we're just rotating the system, our Q is going to be equal to cosine of theta. So cosine of theta. And the next component is going to be sine theta. And then at the bottom, we have negative sine theta. And then finally, we have cosine theta. And again, this is easy to prove. And after we get the answer, if you guys want to stick around, I'll show you guys exactly how I got those values. So we're going to have that right there. And we're going to multiply by the vector u. So on this side right here, we'd have the vector u, which is 2, 3, just like this. So, and I'll pull this down. So something like this. So in this case right here, we're given that our theta, so I'm going to highlight this part right here. Oh, that did not work. Hold on 1 second, guys. Technical difficulties, of course. So this part right here, the only thing we're missing is theta. But luckily for us, the question gives us theta. So theta is equal to 60 degrees. So from this right here, we have a matrix, which we know all the values, and we have a vector, which we know all the values. So all we have to do is substitute in, throw it into our handy dandy calculators, and we find that u prime is going to be equal to, and sorry, I just want to get the brackets kind of right so I don't look like an idiot. And I'm going to use a lot of significant digits. I'm sure it's not going to be this picky on the midterm. So I get u1 prime is equal to 3.598. And we get u2 prime is equal to negative 0.232. 232. Something like that. So a question to change a basis, it's actually pretty simple if you already know Q. And for the midterm, ones that I've seen are usually just the standard rotation. So if it's a standard rotation, you guys can easily figure out that the Q is this, and then you just substitute values, plug and chug. But let's say that you have a question that you don't really know and you have to go to the theory. Well, let's figure out how you can use the original formula to get what you want. So remember that Q is equal, and I'm going to kind of write this in, make it a little bit bigger. So this is the theory part. So you already have your answer, but if you guys want to stick around to see how I got the sines and cosines, this is what we're going to do. So we know this is going to be E1 prime dot with E2. And then moving on to the next one, we got E1 prime again dot E2. And I realized that I messed up the first one. I'm sure that a couple of you guys noticed that mistake right away. I'm not good with proofs, I'll be honest. I'm not the best with proofs. At the bottom, we have E2 prime dot with E1. And then finally, we have E2 prime dot with E2. So if you guys look at this, it's easy to see that the only values that we need to solve for our Q matrix are going to be the vectors E1 and E2, and then E1 prime and E2 prime. So if we look at this, not look at this really, but if we just remember from before, E1 is 1, 0, and E2 is going to be equal to 0, 1. So that's not bad. That's nice and easy from before. So the question becomes, okay, well, what is going to be my E2 prime and my E1 prime? So what I'm going to do really quick is I'm just going to draw another coordinate system, and I'm going to put our new vectors in. So let's say that this is for the general case of a rotation of theta. So something like this. Sorry, takes a little while. So this is going to be our new E1 prime, and we got E2 prime. And I should probably put the original ones up here. So this was our original E2 and our E1. So here's where it gets kind of interesting. So we rotate this by theta. What I can do is I can make a right triangle right here. Just like this. So we got one right triangle, and then on the second side, I can make a second right triangle. Just like this. And what's nice about our original E1 and E2 is they had magnitudes of 1. And that magnitude's not going to change. So basically in this purple vector, this length right here is going to be 1. And then on the other side, it's going to be the same thing. This length right here is going to be 1. And that's easy to prove because if we look at our E1 and E2, which I guess I'll highlight right here, the magnitude of those vectors is 1. So nice and simple. So from here, we can easily find the components just by using simple trigonometry, because that theta that we rotated by down there, that's also going to be the theta over on this side. So all we have to do to figure out our vectors is just by looking at it and using simple trigonometry. So for E1 prime, we know that the first component is going to be kind of the new x component, which is going to be this right here. And in order to get this value, we times the hypotenuse by cosine of theta. But since the hypotenuse is just 1, this is just going to be equal to cosine of theta. And then we can move on to the vertical components, which is this one right here, which is going to be the hypotenuse times sine theta. But the hypotenuse, again, being 1, all we get here is sine of theta. So that right there is our E1. And we can go to the other side and say, okay, well, E2 prime, and do the same thing. So our horizontal component is going to be this component from here to here. And we realize that to get that component using that triangle, it's going to be sine theta. But now we have to recognize that this is now going into the negative direction. And since it's going to the negative direction, this would be negative sine of theta. And then similarly, we can conclude that the height of this is going to be cosine of theta. So from there, we now have our new basis vectors e prime, e1 prime, and e2 prime. So if we look at the thing, all we have to do is dot these vectors together to get our final components. So what I'm going to do is I'm going to just go down the list. So our first one is e1 prime dot with e1. So remember, we're just taking the first components and multiplying them together, then multiply the second components to get a scalar. So the first component of e1 prime is cosine of theta. So I'm just going to put cosine of theta. And then we multiply this by the first component of e1 prime, which we can see up there is just 1. So this is going to be times by 1. And then plus the second component of e1 prime, which is sine theta. Oops. I need to keep it consistent. Sometimes I put the brackets around theta, sometimes I don't. In this case, I'm not going to. And we multiply that by the second component of e1, which is 0. So from here, we can see that cosine theta times 1, well, that's just going to be cosine of theta. And this time I will put the brackets, just to really confuse you all. And then sine of theta times 0, well, that's going to be 0. So we can tell that our first component of q is going to be cosine of theta. Now I can go down the list and go e1 prime dot with e2 now. What we find is that we have the first component of e1 prime, which we remember as cosine of theta. And then we multiply that by the first component of e2. And I'm going to highlight it up here, just right here, so you guys can see or provide reference to yourselves. The first component there is 0. So this one's going to be times by 0. And now we do the second component. So again, we have the sine theta multiplied by the second component, but this time the second component is 1. So from here, we got 1, and we can put them together to figure out that this is going to be just sine of theta. Moving down the list, we got e2 prime multiplied by e1. And in this case, now we're looking at our second new vector, which is this one right here. So to get this one, same thing as before, we're going to take the first component, which is negative sine theta. And we're going to multiply this by the first component of e1, which is 1, plus the second component of e2 prime, which is cosine of theta. And we're going to multiply that by the second component of e1, which is 0. So in this case, we get negative sine of theta. And then finally, our last one, we got e2 prime dot with e2. And what we get is the first components are going to stay the same because it's the same vector. So we're going to get, oops, I make it sound like it's going to be nice and easy. And then of course, myself, I get it wrong. So we get negative sine of theta multiplied by the first component of e2, which is 0, plus the second component of e2 prime, which is cosine theta, multiplied by the second component of e2, which is 1. So in the end, we get cosine of theta. So all I have to do is take these values and substitute them back into that original matrix right there, Q. And in the end, I get that Q is going to be equal to, and I'll put my matrix brackets right here, matrix tensor, whatever you want to call it. And I get cosine of theta. And then the second one's going to be sine of theta. And in the bottom left, we're going to have negative sine theta. And finally, we're going to get cosine theta. So that's how you kind of derive something if you're given a case you're not familiar with. Again, usually a lot of the midterm cases you will be familiar with. So if it's me doing it, just have the formulas ready. Get yourself that nice easy mark. Don't worry about this too much. But if you guys are in a higher level class, you guys will need to know this. And probably since I ran my mouth in this video and said just memorize them, Dr. Deeb will come up with something juicy to really screw you guys over in the midterm. But he's usually a nice guy, so don't worry about that too much. Maybe it's just me. All right, so that concludes this little video tutorial. Like I said, this quiz, rather nice, rather short. I hope you guys learned something, what a change of basis is, and then hopefully you guys will see later on in life why we use it. So thank you guys all so much for listening. I'll see you guys in quiz number 7.